Hello everybody, my name is Eric, and today we're going to be doing a deep dive into well, I don't know if I should, yeah, it's definitely the most famous piece of malware that I have ever covered, famous because of me, that is CONHOZ.exe. CONHOZ.exe is what appears to be a Windows XP worm that is the main payload that got installed when I exposed Windows XP to the internet for the first time. It showed up about 10 minutes later. When I exposed XP to the internet a second time, the same version of XP, nothing happened, so I don't know if the campaign is no longer running. Now, from a bit of static analysis, it doesn't actually seem like it's a worm so much as a command and controlled malware, so there may be a dropper involved, but let's just run the file. Now, what I've got here is a tool called FakeNet. Now, what FakeNet does, and I'm also going to use this on Redstar, so if you want to see what Redstar would do if you were connected to the North Korean intranet, please subscribe. So what this is going to do is it will pretend that we're connected to the internet. I'm thinking I may have made a mistake in the patched version of CONHOZ that was supposed to kill the debug check. I may have made it always true instead of always false, because it seems like, well, let's just check if Microsoft compilation CONHOZ is still running, or if it's still instantly killing itself. Oh, we've got some packets. Okay. Now, of course, I'm using VMware tools with shared folders enabled, which is not smart for malware. I'm confident enough this does not have an escape payload because I have already seen most of its source or decompiled code. And I'm, of course, using a Linux host with Windows malware. But if both of those conditions are not met, do not do what I am doing. But just because I'm going to copy and paste these onto my Linux system, just why I can do that. It's like we can only copy into XP, but not out. So it seems like the DNS functionality. I wonder if we do have to turn the network adapter on. Oh, this could be a hit. It's trying to find an internet gateway device, but bind call failed on 1034, so it's listening to something at 1034. It's quite a strange version of Wireshark, but it seems to work, because we need to be able to open PCAP files, and Wireshark can do that. Okay, so I think what we need to do is copy and paste that to a file so that it's not... Okay. So the only way we can do that is to kill FakeNet. I'm going to start it up again just so that, because the moment we kill it, in theory, something could access the real internet, but now we have a copy. Okay, so I think the actual CONHOZ payload only seems to run under system, so we're going to have to go to scheduled tasks, and ideally we can just run it. Okay, every 5 minutes. Okay, and I'm going to actually add a pipe here so that we get a log, because CONHOZ has command line logging for whatever reason. Oh, so now we did succeed at getting a request. So we did need to be on the internet. Now, okay, so this is where the 816 hit. Now, a guy in my Discord who is probably the best static analyst I have ever met, or maybe not, just like decompiling, found some really interesting stuff. So the actual, I know what the IP address for that is, but I didn't know what the text was. So let's just open in a browser that URL, or a curl. You can use a curl. Because the only sample I found... So this is going to be cmd.cmd-23088112.ru :816. Now, as far as I know, this looks like it's a hacked Chinese server. Okay. So this is some sort of kind of janky. Okay. So here are the additional payloads. So this is actually a dropper. So we get users.raw. So that, I believe, is what creates admin A, but we can double check. Now, that's a strange way of doing it, if I'm right, because creating a user account by copying a user.dat is the least portable way you could possibly do it. So these are the files that should go where. And these are all clearly running the same file system. Okay, we're going to download all of these and analyze them. ce.raw. This one might be dead, or it might not like me. Okay. u.exe. New.exe seems to be offline. Oh no, that's because I copy and pasted a pipe. I've done that twice. That's kind of embarrassing. Now, we don't need rocket science to figure out this is a Monero miner, which is genuinely an odd use of what appears to be a Windows XP worm. This is a different file, and then WMIA is going to be a command that I imagine is going to ask to execute. Now, let's just see if we were to tweak the rand here. Does anything happen? No. So that's simply a piece of tracking. Okay. Now this is the other command, make dr ASP.NET. Now, of course, okay. And here is what I was actually most after. Because this is quite likely, this is actually in the CONHOZ.exe file for whatever reason. So there may be a bit of duplication here, but okay. So I'm just going to save this. Now this installs a malicious service called the XWinWPD service. Debugger, okay. Now this also removes CONHOZ for whatever reason. Okay, and the debug item.dat, which I think was on the previous payload, so this is an executable. Because you could hide executables using run.dll. Delete. So okay, that's kind of weird how it actually puts a lot of. So now this I think is some sort of info stealer. So what are we gonna do? Well, we're gonna connect to it. Some sort of successful. And this is the other interesting thing. Now I've seen this before in the Welchia virus. So it actually is adding a deny to the ports that the worm actually needs to execute. So while, of course, unlike the Welchia virus, they're not doing this for any altruistic reason. These guys don't just take over your vulnerable SMB. They actually block out anyone else. So now we have... Okay, and so these domains are all related. Now, I mean, I don't know how hosts exactly works on Windows. On Unix, this would not... I don't... that should redirect... So unless this is a rival... that command does not make sense to me. And then we create temp, and then we delete the evidence of us ever running this command. Now, unfortunately, this... Oh. So this one still works. So these are our... Okay, and it's not actually a rel file, it's an exe file. That's why... Well, of course, because there'd be no good way of extracting such a file on Windows XP. It's UPX packed, so is CONHOZ, which is trivially easy to bypass. Okay, so it does a couple of things. Okay. Now we can try the bogus rel files. I'm not uploading in. What? Oh, the download actually broke on this one. Okay. Is that because... Oh, that's already... Okay. Well, let's try renaming it to .exe so that VirusTotal will realize it's executable. Doesn't. Okay, let's demand that it reanalyze the exe. So that at least the sandboxes will run. But that's interesting. So it seems like you can completely... Let's try this with the XML rel just to validate. Okay. So it does catch... Okay, so if you first upload a rel to VirusTotal, it seems to defeat it unless you click reanalyze. But if it's xmrig, then we can prove this is a Monero miner, which is one of the ways these people are going to get money, in theory. Of course, we could find out what their Monero address is, but we found their Monero address, so who cares? You can't do anything with that. And this one is a Trojan called PC Share. This is actually 99% of what I use VirusTotal for. I use it mostly as an open source intelligence tool where you can see what other names that a file has been distributed as. So these are all pretty common packages. Then we get a bunch of different sandboxes that all backlink here. Okay, we can try out. And this is the only one that was directly shipped as an exe. Graftor. adware. Okay, the wanna mine. So is this another mine? What is wanna mine? Makes me think though that this actually could be the. Okay, so this is in fact a worm. It's Eternal Blue, which XP Service Pack 3 is vulnerable to. This is not the same. Yeah, and it pretends to be service host. And this is theoretically, so despite the fact that in my random testing, I never got hit with this on 7, this payload would work on Windows 7. So it's not purely a Windows XP problem. So I can also now, let's just go to Binary Ninja, and I'll show you some of the interesting pieces of the decompilation of CONHOZ.exe. This is Binary Ninja. This is something that the guy I was mentioning who's really good at reverse engineering introduced me to. It is proprietary, but it has a really nice UI, and it has like all these different levels. I only have on this version a few of them, but you can go from assembly, which to most people just looks like some totally insane hacker language, to then you can go to the intermediate language, and there's different levels. And this isn't exactly C pseudocode because it's got some conventions. Like we have register names. EAX is one of the registers that an x64 CPU is. But one of the things they've done is they've normalized this. So if I were to say on my Apple Silicon Mac, open an ARM binary, the intermediate language is approximately the same, whereas the disassembly is different because the CPU is different. So it serves a different purpose. Now this is the function I was paying quite a bit of attention to. I've called it FTP Connect. That was renamed by me. And we can see some things, and we can see, so there's an IP stored in base64 in this file. There's several actually, which FitBlip, the guy I was mentioning, found all of them. So Internet OpenW, this uses this decoded IP address to connect to an FTP client at port 21. That was the FTP port that wouldn't open for me, but it did open in the video, so it definitely existed at some point. So it'll either fail to open an internet connection. Here we can go through, and here we go. We get all of this, the username and password, and there we go. Now, one thing that makes this a bit less interesting, well, this actually seems to be a different upload, is the fact that these uploads are not randomized means it's unlikely that if we were to connect to this FTP server, we would just find a dump. It's much more likely that it may not even be a genuine FTP server on the other end. It might just be like sort of just a way of using it to upload files. Failed to download, and then so it seems like it tries to. This could be a different function. And then if this works, so the status of this, as is fairly conventional for the Windows API, is returned, and usually any values that are affected are going to be done so via references. So if the status is not 0, we break. If the status is 0, we go. Or no, if the status is 0, we break. If we don't, and then we kind of try this again, and we loop, and then we close this connection, and then we deallocate a string, and then do, so there's a while loop going on here, and here's the file that we were trying to download. Here's in the data section. This is where, this is one of the things. This is actually the world's most stealthy IP grabber. It just returns the IP of the person who called it. First request URL, first request response. Now, the most bizarre thing is the amount of logging in this. And as I found by adding a pipe, this is not disabled. You hear of a stripped build. Well, this seems like they almost shipped a debug build. You could have, why do you have logging? UID, send request to a double base 64. There we go. Login info. Accept OK. Sending. So it gets our public IP address from that. MAC address might be for NTVM. There's no client-side anti-VM. Okay. And this is like fairly typical Stealer things. Oh, and here, so it seems like the script that it downloads is actually bundled. This program has to be destroyed. So here is, this was the magic file. Here's the old date. And here's how this all works. Because of course on Windows XP, you could even use this to log in as system, because Windows XP didn't stop you from doing that. Now there's some other interesting things. If we go on over to the triage summary, we can learn quite a few things. The most shocking thing, because in one of my videos, I kind of even joked, well, who's creating Windows XP malware? It's not an old worm that was still running. If we expose SP0 to the internet, that is probably what we would find. But if you expose SP3, it's going to be an eternal blue exploit, and it seems there is still money in doing this. Either that, or simply they just thought there would be. That also could explain that all those XP computers we found on Shodan with the vulnerable ports closed may in fact, given this blocks them, be targeted. So it's a 32-bit system, terminal serverware, NX compact, and it's compiled seemingly with 2022 Visual Studio, and it was compiled allegedly in January of this year. It doesn't have to be updated that often because it uses a nest of servers to find the current command and control. So if one of them dies, it's okay. So the final thing we're going to do is, of course, head on over to Shodan to take a look at the IP addresses that seem to be involved. So this is a San Jose server. It's got this is an ASN I've never heard of, and it's Windows. It's what looks like an obsolete Windows server, which seems to be a pattern because most of these were in China, but they all seem to be running very old versions of IIS, and as we all know, running old versions of Microsoft software on the internet is a very bad move. So let's try the next one, and some of these seem to be dead, which would also be quite common. Okay, this is another PegTech server. Okay, and PegTech is a huge ASN, so 2 million IPs. Medium fraud risk. Pegasus Technologies. There's some people saying that some people blocking their entire range. Okay, so this is a proxy that allows. Okay, so this is a China-based proxy. That makes more sense. So that's how we have these Chinese-looking IP. And then let's try this one as well. This is the one that shipped 2 payloads. Check I typed it properly. Okay, this is from Vulture, which is, well, it says it's got Vulture in the host name. And then it's got Korea Republic, Peripunk, the Constant Company LLC. So we've got an American company that is got a server in South Korea. We can see mostly the normal ports on this. So this one actually may not be even affected. Now, one way we could something we could see in terms of the one that didn't work is whether got a few 404s. Okay, that one still works. Is whether swapping the IPs. Let's actually try it. See if all of these IPs actually have the files, because that would make some degree of sense. Doesn't. Okay. Now, if we do the chris.lu on Shodan, as I've already done, now, these could, once again, these could be hacked computers, the way this is behaving, because if this is pointing to localhost, it's a very strange setup. So it seems like the answer to what does CONHOZ do is it's some sort of Russian exploit of Eternal Blue that mines Monero and also has an info stealer. But the main purpose is mining Monero, because realistically, any computer running a Eternal Blue vulnerable operating system that is exposed to the internet is either someone's misconfigured server or possibly a PC that they're paying for internet for but just don't use anymore. It's very unlikely that it's in active use. So these are probably better ways of making money. I don't think it's highly profitable because no computer newer than 2012 is likely to be running these operating systems. So I think it's just got to be like a herd thing. And I guess realistically, because Monero can't be traced, it's free money. So that's basically what they're doing. It's not rocket science, but I still thought it was kind of cool to go through this. Huge shout out to FitBlip for helping me with the static analysis. That's all for now. Bye.